What's up, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, welcome to episode 3 of our series entitled Math Teaser Alert, where we answer math questions that help sharpen your critical thinking skills and your problem-solving skills. All right, so without further ado, like Judge Mills Lane used to say, let's get it on. All right, so our question reads, x squared minus 7x plus 11 raised to the power of x squared minus 13x plus 42 equals 1. And we want to solve for x. So we have a power problem, but the numbers themselves are written in quadratic form. The base is a quadratic equation and the power is also a quadratic equation. Right? So it does look weird, does look a little confusing, but as long as we break it down to its basic fundamental parts, it actually makes the process of solving it a lot easier to handle. So what's basically happening here? Well, if we knew the value of x, this would be a number. If we knew the value of x here, this would also be a number. So it's basically a number raised to another number. So a number to a power. And when you do that, the answer is supposed to be 1. Okay, well, with that being said, there are only 3 scenarios where that can occur. So for a number to be raised to a power and equals 1, one case is that the base of this power is 1. Because 1 raised to any power is equal to 1. The second case is when the power itself equals 0. Because a number raised to the power of 0 also equals 1. There's a third case, which most people might not see or might not be able to get at least, off the bat. But it's when the value of the base equals -1 and the value of the power is an even number. So -1 raised to an even power actually equals 1 as well. -1 squared, -1 to the 4th, -1 to the 6th, they all equal 1. So those would be our 3 cases. So let's solve for each one. So the first case was that as long as the base is equal to 1, it should work. So we can set that up. X squared minus 7x plus 11 equals 1. And we just solve that. So I would subtract 1 from both sides. You get x squared minus 7x minus 10 equals 0. So it's a quadratic equation where we have to find factors of the last number that add to the middle. So factors of positive 10. I don't know why I wrote -10. Positive 10 that equal -7. So that would be -5 and -2. So the 2 binomials would then read x minus 5 and x minus 2 equaling 0. And you would apply the 0 product rule here, which basically says that x is equal to 5 and x is also equal to 2. All right. So now we have 2 values of x that would make the base of our power 1. And then whatever the power is up here would then allow it to be equal to 1 in the end. All right, so we have these 2. That's one scenario. Scenario 2 is when the value of the power is equal to 0. So let's set that up and solve for that. So the power says x squared minus 13x plus 42. And we want that to equal 0. Okay, cool. So it's already set equal to 0. Good. That means we can apply the AC method or factor in the old-fashioned way, which is factors of 42 that add to -13. If you haven't checked out my video on factoring equations, you should definitely check that out now after this video when you get a chance. So factors of 42 that add to negative 13 would be negative 7 and negative 6. Negative 7 times negative 6 is 42, and negative 7 plus negative 6 is negative 13. So those two values become our numbers inside our binomials. So x minus 7 and x minus 6 equaling 0. And again, we apply the zero product rule, which just means that we're going to take the opposite values of these numbers inside. So x would then be equal to 7 and 6. And we have two more values of x that work. All right. And now our third case. So the third case is when the value of the base is equal to negative 1 and the value of the power is equal to an even number. So we can set that up once again. So we'll set the base equal to negative 1. So x squared minus 7x plus 11 is equal to negative 1. All right. And we just solve it like we would any other quadratic equation. So we're going to add 1 to both sides. That's going to give us x squared minus 7x plus 12 equaling 0. All right, and we're just going to factor this the old-fashioned way by finding factors of 12 that add to negative 7. All right, so in this case, those values would be negative 4 and negative 3. Negative 4 times negative 3 is 12, and negative 4 plus negative 3 is negative 7. So those two numbers are going to be exactly what we're going to put inside our binomials. So we have x minus 4 and x minus 3 equaling 0. And again, we apply the zero product rule, which means that the values of x are going to be just the opposite values of the numbers in the inside. So x would be equal to 4 and 3. And these would be the values of x. But we have to be sure that they work, because the other part of this scenario was that the value of the power had to be an even number. So we know what makes the base negative 1. It has to be 4 and 3. But we have to make sure that this is equal to an even number. So the way to do that is to take these two numbers and plug it into this equation and see if you get an even number as an answer. So let me try it with another one. I'll do this in black. So we'll take 4. So 4 squared minus 13 times 4 plus 42. Right? So 4 squared is 16. 13 times 4 is 52. And we're going to add 42 to that. All right, and when you combine all of this, let's see, 16 minus 52 is a negative 36. And if you add 42 to that, you get 6. So, voila, even number. So 4 happens to work. Now we have to try it for 3. All right, so when we plug 3 into it, we get 3 squared minus 13x, minus 13 times 3, plus 42. All right, so 3 squared minus 13 times 3 plus 42. 3 squared is 9. 13 times 3 is 39. And add 42 after. So 9 minus 39 is negative 30. And adding 42. And negative 30 plus 42 is 12. Voila, another even number. So 3 works as well. So these are your 3 scenarios in green, blue, and red where this problem would equal 1. We found our 6 values, or 6 solutions in this case, that would work. X can be 5 and 2, or 7 or 6, or 5 or 3.
4 or 3
in this case. All right, there you have it, folks. That's another edition of the Black Math Academy demonstrating its thing. I hope that this problem lit a fire for a passion for learning and a passion for mathematics. Don't forget to like, share, comment, subscribe, and follow all of our social media pages, our Facebook, our Instagram, and our YouTube. And I'll see you guys in the next episode.